Okay, we're still
Go
talking.
Ryan with
We're still talking about equivalent fractions, and I found some new resources to use. They're going to be pretty good. Let me show you what we got here. I'll give it to everybody. This is a math resource we used last year when we were teaching fractions. I figured we'd get back into it. Okay, so we have this equivalent fractions activity in our Seesaw now. And I'm going to bring up mine. So you have this in yours. These first few slides are something that I'm going to take you through together. And then the other slides are going to be ones for you to work on. But right now, we should all be looking at this one. I know some of you were trying to go to Seesaw and look at it yourself while I was teaching it. If that doesn't work for you, you can just watch me here. All right? So let's be paying attention as I start. Let's look at what our goals are. So you will use fraction models to write equivalent fractions and tell whether two fractions are equivalent or not equivalent. So by fraction models, they mean the pictures here. And our question is, how can you use models to show equivalent fractions? So let's pay attention while I read this here. Okay, it says, Joe cut a pan of lasagna into third size pieces. So meaning 3 equal pieces. He kept 1/3 and gave the rest away. Joe will not eat his part all at once. How can he cut his part into smaller, equal-sized pieces? So here's the plate of lasagna, all right? And we see 1, 2, 3 equal parts. And he gave 2 of them away, and then he kept this for himself. So we could say he kept 1/3, right? And now look what it says. He's not going to eat it all at once. He's going to eat it in smaller parts. So it says, draw on the model how to show Joe could cut his part of the lasagna into 2 equal pieces. Paying attention, Christian? So if I go to my marker here, we want to cut this into 2 equal pieces, and we could do that right here like that. Now it's in 2 equal pieces, right? Then it says, suppose Joe cut the original pan of lasagna into equal pieces this size. So what if he cut the whole thing into pieces that size? Then it would look like this, right? How many pieces are there now? If you look at the lasagna pan, how many pieces are there now, Daniel?
6.
6, right. And then what fraction would be 1 piece here? Just 1 piece like that. What we have 6 pieces here. What would be just 1 piece? What fraction would that be, Lexi?
1/6.
1/6.
Yep.
Then, so what fraction would be 2 pieces then? Well, that would be 2/6, right?
Mm-hmm.
So here we can see that you can rename 1/3. So we had 1/3 here, right? This is still 1/3, like that. But we can also call it 2/6. So 1/3 is equivalent to 2/6. We can see it in there, right? So let's look at this next one here. We're going to draw on this model to show how Joe could cut his part of lasagna into 4 equal pieces. So it's the same pan, same lasagna. Here he cut it into 2 equal pieces. Now we want to cut it into 4 equal pieces. Let's see. We've got 1, 2, 3, 4, 5, 6, 7, 8 rows. We should do like 2 rows at a time. Now we've got 4 equal pieces, right? And we can rename them as pieces like, let's suppose that he cut it all like that. Adeline, how many pieces are now in the lasagna?
12.
1, 2, 3, 4, 8, 12. You're right. There are 12. So, Adeline, what fraction would be just one piece right here?
1/12.
Very good. And then what about all four of the pieces? What fraction would that be?
4/12.
Yep, 4/12. So that means 1/3 can be renamed as 4/12. An example of equivalent fractions. So we talked about equivalent fractions yesterday, fractions that show the same amount. And we can say that 2/3 or 1/3 is equivalent to 2/6, like we saw in the last one. And it's equivalent to 4/12. Like
Yep.
this. All
So
right.
it's not hard.
Not really. So we started out with 1/3, right? And here we showed how it could be renamed as 2/6. And then here we showed how 1/3 could be renamed as 4/12. All right.
Yeah.
Okay. What I want everybody to do now is go into Seesaw and bring up this assignment. So everybody go there. This includes you, Christian. Tell you're not really paying attention. Go into Seesaw and go into this assignment. It'll say, let's see, title of it is equivalent fractions. So it's right there. And now, like I said, if that means you have to go back and forth between the Zoom meeting and there, that's fine. But you should always be listening, right? In case I call upon you. And we are looking at, let me go back to mine. Oh, it erased all my changes. Why did it do that? So let's go here to the third one. We shall all be at the third slide where it says share and show. We all there? Okay, so here it says use the model to write an equivalent fraction. So we could see that we've got 1/5 here. We got 1, 2, 3, 4, 5 parts and one shaded in. Well, what could we do here to change it to show that there's an equivalent fraction? Any suggestions? What can we do to this model? Tell me one thing we could do to this picture here.
Split it in half.
Okay, make a line right down the middle. Says Hallie. So like this. All right. So Hallie, how many parts are there now?
10.
The message. Don't.
And how many are shaded in?
Oh,
2.
Adrian's
What-
voicemail
What equivalent fraction did we just make?
has a message for you.
2
Of course, 'cause
tenths.
it's,
Very
your
good.
phone. Well,
So you can say that 1/5 is equivalent to 2/10. Good. How about the second one? We've got 2/3 showing. How can we change this picture? Joseph, what can we do to this picture to create an equivalent fraction? Any ideas? I have a couple. We could do this. We split it. Wait, no, that's not right. Got to go one over. Let me get my eraser. We split it. Let's see. There's one. What we got? 2/3. How many columns are there? 1, 2, 3, 4, 5, 6, 7, 8. It's hard to count. Nope, that's not right either. We want to try, I'm trying to split it right down the middle. There we go. Now we've got 1, 2, 3, 4, 5, 6. And we got 1, 2, 3, 4 shaded in, so that's 4/6. Anybody see a different way we could split this one? What if we did this? Let's see. Does this work? Maybe go every third one. Come on, marker.
Kind of hard to draw a line.
What about like that? Now how many parts do we have, Daniel?
4.
No. Count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
12.
We got 12. And how many of the 12 are colored in? We got 12 in the hole. 1, 2, 3, 4, 5, 6, 7, 8. So we say 8/12, right? So that's another way. Can we see even another way we could do this? I think I can. Let's think. Nah, maybe not. What if we did this? Now we're good. We're good. So we can see that 2/3 is equivalent to 4/6, and it's equivalent to 8/12. All right. Now everybody look down here at these 3, 4, 5, 6, 7, 8. They want you to decide if these are equivalent or not. If they're equivalent, you give it an equal sign, like that. If they're not equivalent, you make the equal sign with a slash through it, like that. All right. So, problem here is we don't have any models to go on. So I'm curious what they want us to do. What's another strategy we could use besides using these models? Anyone have a suggestion of what we could do to see if these are equivalent? Okay, I didn't think so. So I'm going to show you another way. All right. What I want everyone to do is if you do not see my screen right now, I want you to leave Seesaw and come back so that you're definitely watching me. All right. So is everybody here off their own and watching mine?
Yep.
Okay, there's something important I want to show you. Let's go back to all of these. So this one, they said, split his part into 2 parts. So we started with 1/3, right? And then we made 6 parts. And then one part of that was 1/6. And then 2 parts is 2/6. And then the last part is 1/3, can be renamed as 2/6. They're equivalent, right? And I want to show you guys this. So pay attention. So we got 1/3, and it's equivalent to 2/6. I want you to notice it. We can take 1 and multiply it by 2, and we'll get 2. We can take 3 and multiply it by the same thing, 2, and we'll get 6. Because you can see that when we made this line, we multiplied everything by 2. The number in here by 2, and then the number of all parts by 2. We'll look at this one. Here it said split it into 4 equal pieces. So I meant to do this. And now that shows that we have 12 pieces. And that one piece of those is 1/12. And then the whole part in blue would be 4/12. Well, that's ugly. So that tells us that 1/3 is the same as 4/12. Now watch this. Let's put them over here. So we know 1/3 is equivalent to 4/12. So we know if we take 1 and multiply it by 4, we get 4. We take 3 and multiply it by the same thing, we get 12. You guys picking up on the pattern here? Multiply numerator and the denominator by the same thing, you're ending up with equivalent fractions. Is anybody seeing that?
Mm-hmm.
That's the point I'm making. So then over here, so we have these fractions down here. They want you to tell if they're equivalent or not. Well, do this then. Think. Joseph, 1/6 and 2/12. Let's find out if they're equivalent. What, Joseph, what do you multiply 1 by to get 2? 1 times what equals 2? Shimon Joseph, 1 times what equals 2?
1,
1 times 1 equals 2?
2.
1 times 2 equals 2. So we can multiply the numerator by 2 and get 2. What about the denominator here? Does 6 times 2 equal 12? Joseph?
No,
It doesn't?
no, it doesn't.
What does 6 times 2 equal?
Oh, wait. Yeah, it does.
So,
For a second there, I thought you said 6 plus 2.
oh no. 1 times 2 equals 2. 6 times 2 equals 12. Can we say that we multiplied both numerator and denominator by the same thing to get these two numbers? Would you agree with that? We all see what I'm talking about? You multiply numerator and the denominator by the same thing, you can create an equivalent fraction. You see that? I hope you're seeing that. Let's look at it this way. So this is 1/6 and 2/12. Well, let me make a picture here.
Are we making this?
You should just be watching me. Are you watching me?
Yes.
Okay, that's what I really want you to be doing right now. So check this out. So here's 1/6, right? Now
Yeah.
watch. So then if I do this, whoops. Oh well, I made a big old fat line. Can we see that I just multiplied all the parts by 2? You see that? Did everybody see that?
Yes.
We could say we took the 6 parts and multiplied them by 2. Now we've got 12 parts. And then the parts that were colored, we had 1, and now it's multiplied by 2. So we multiply both numerator and the denominator by the same thing. We can get we get an equivalent fraction. What about this one? 2/5 and 6/10. Let's see if they're equivalent. What times 2 equals 6, Lexi?
2 times 3.
2 times 3. Well, does 5 times 3 equal 10?
No.
No. So this one doesn't work, does it? 2 times 3 equals 6, but 5 times 2 equals 10. You're not multiplying by the same thing. So, whoops, I need to get rid of that fat one. There we go. Make it skinny again. So that means these two are not equivalent. They are not equivalent. What about 4/12 and 1/3? Let's think about that. Now, they're reversed. You wouldn't multiply 4 by anything and get 1. So start with the smaller one and go that way. So start with 1 here. What 1 times 4 equals 4, right? Does 3 times 4 equal 12, Hallie? Does 3 times 4 equal 12?
Yes.
Yes. So 1 times 4 equals 4. 3 times 4 equals 12. These are both multiplied by the same thing. So yes, these are equivalent. And this is one that you can look in the picture. Here we see 1/3. We got 2/3 colored in. We'll just look at the 1/3. And let's try to multiply the number of parts by 4. Well, we could do that by splitting it into 4 parts. We just did that. So by splitting 1, 2, 3, 4, we just multiplied everything by 4. So just look at this part up here, just this one top row. It's the same as this row. This we would call 1/3, 1 out of 3 parts. This 1, 2, 3, 4 out of 12 parts. So they are equivalent. 5/8, 2/4, equivalent or not equivalent? Can you multiply numerator and denominator by the same thing? Can you multiply 2 and 4 by the same thing and get 5 and 8? Here's a question. Can you multiply 2 by anything and get 5?
No.
No. So these are already, you know, they're not equivalent because you can't multiply 2 by anything and get 5. What about 5/6 and 10/12? Can you multiply 5 and 6 by the same number and get these two numbers? Let's ask Donald. Donald, 5 times what equals 10?
What?
5 times what equals 10? What do you multiply 5 by to get 10?
2.
What about 6 and 12? Does 6 times 2 equal 12?
Yeah.
Yeah, so that means these are equivalent, right? Remember, if you can multiply numerator and denominator by the same thing and get these two numbers, then you've got an equivalent fraction. 1/2 and 5/10. What do you say, Adeline? Are they equivalent or not equivalent?
Not equivalent.
What times 1 equals 5? Adeline?
1 times 5.
Okay, then what about 2? Does 2 times 5 equal 10?
Yeah.
Well, that means you multiplied both numerator and denominator by the same thing, right? And got these two. So I mean that they are equivalent. All right. So what if you show this with the picture? Here's 1/2, right? Color it in, color it in. And then if you want to make it the tenths, that means you gotta multiply it by 5. So that means we need to split this into 5 parts. You see with these lines, we just multiplied everything by 5. We went from 2 parts to 10. And we went from 1 colored in part to 5 colored in parts, but it's still all the same amount. So do we see the connection between multiplication and equivalent fractions? I'm hoping
Yes.
you are. Hoping you are. So when we come back from lunch, you will be working on this slide here. And look, you don't have a lot to do. This one's already done. So you use this picture to create an equivalent fraction. And then down here, you decide if these are equivalent or not equivalent. All right. And when we come back from lunch, I'm not going to have you work on this all on your own. I'll be around to help. So we might make some breakout rooms for you to work on it. So this is a new resource. I think it's pretty good. So let's go ahead and leave for lunch a few minutes early. And I will see you right at 12, okay? Okay.
I did.
See you at 12.